a stunning new assessment of national numbers.
These new numbers on attention deficit hyperactivity disorder.
Attention deficit hyperactivity
Let's
disorder.
take a look at ADHD.
It's about attention deficit, ADHD.
6.4 million children ages 4 through 17 have ADHD.
19% of high school boys, nearly 1 in 5, have been diagnosed with ADHD.
11% of all kids in our nation
Are diagnosed with ADHD every year.
Millions of kids have ADHD.
with attention deficit disorders.
1 in 5 high school boys diagnosed with ADHD.
Prescriptions with amphetamine-type drugs to help treat the disorder.
Medication for ADD, attention deficit disorder.
It's a drug we've all heard about, widely prescribed for attention deficit
So
disorders.
prescription medications like Adderall
or psychostimulants like Adderall.
Adderall use has
Adderall is
exploded.
a legal prescription drug available at any
Adderall
pharmacy.
is meant for people with attention deficit disorder.
14 million prescriptions for Adderall were filled last year.
How students are using Adderall to keep them alert.
hoping for sharper focus and better grades.
Many students take the drugs to enhance their performance on examination.
It does enhance their
Stimulates
performance.
the brain. It kind of puts the brain in overdrive.
Sound familiar? We've all heard about Adderall and ADHD, but what's the story behind that 4-letter acronym? And how could a tiny little pill act to change a person's behavior? In order to answer these questions, let's start with something with which you're probably already familiar. What does ADHD look like? Attention deficit hyperactivity disorder is characterized by specific behaviors that make up the fundamental criteria for diagnosing a person with ADHD. The 3 main criteria are inattention, hyperactivity, and impulsivity. Let's just focus on inattention. What's the purpose of attention anyway? Why would we want to focus our attention on just one thing rather than being able to focus on a bunch of stuff at once? Well, we can imagine that in more primitive times, humans had to be able to utilize attention in order to survive in potentially life-threatening situations, like paying attention to certain sounds or visual cues from their environment when doing something like hunting in order to avoid an unfortunate encounter with a lion. But with so many things that are available to stimulate our attention nowadays, like technology, the ability to disregard inconsequential stimuli, or noise, is important for acting appropriately in social situations, or being successful at school or work, or just in our daily lives. To put things into perspective, let's take a look at some of the characteristic behavior that is associated with inattention type ADHD. Often does not seem to listen when spoken to directly.
Uh-oh, here it comes.
Often avoids, dislikes, or is reluctant to engage in tasks that require sustained mental effort. Often loses things necessary for tasks or activities. Has difficulty with organization. Is often forgetful in daily activities. Often doesn't follow through on instructions and fails to finish schoolwork, chores, or duties in the workplace.
Listen, baby, ain't no mountain high, ain't no valley low, ain't no river wide enough, baby.
Just call my name, I'll be there in a hurry. You don't have to worry.
Is often easily distracted by extraneous stimuli.
Wouldn't it be nice if we were older, then we wouldn't have to wait so long?
Clearly, struggling with attention can be quite problematic. But what controls our ability to pay attention? The brain. It turns out that the exact biological causes of ADHD are in fact quite the mystery. However, there is a bunch of stuff we do know, and some stuff you'll need to know in order to understand how Adderall can influence behavior. First, you need to know a little bit about the brain. It turns out that our brains are divided into different regions. Those regions contain subregions that we know are associated with specific functions and behaviors, such as language, vision, motor control, and what we're focusing on, higher mental functions, otherwise known as executive functions. The region at the front of your brain, called the prefrontal cortex, mediates these executive functions such as planning, decision-making, working memory, and higher-level attention and selective attention. But how does information get from stimuli into our brains? The answer is that it all happens within the nervous system, which is made up of tons of neurons, which you might remember from their resemblance to the trees from the Lorax. Trillions of neurons are bundled up to form nerves, which act as pathways for the transmission of signals to your brain. Receptor neurons are stimulated by stimuli in your environment, which causes them to send signals to your brain. Once it processes that information, it sends signals out to your body along different nerve pathways to make us do stuff. The part of the neuron that looks like the bushy part of the Lorax tree is called the dendrite, which receives information from other neurons. The trunk of the tree is called the axon, along which the signal travels before it reaches the end of the axon, called the axon terminal, where the signal can then be passed on to another neuron. The place where the axon's branches almost come into contact with other neurons' dendrites is called the synapse, where it passes the signal on to the next neuron. When a signal reaches the end of an axon, it transmits the signal to the next neuron by releasing little chemicals called neurotransmitters. The released neurotransmitters travel from the presynaptic neuron, or the signal-sending neuron, across what's called the synaptic cleft, and then bind to receptors on the dendrite of the postsynaptic neuron, or the signal-receiving neuron. The binding of neurotransmitters to receptors on the postsynaptic neuron stimulates that neuron to pass on the signal. After the neurotransmitters bind to the receptors on the postsynaptic neuron, they are then released back into the synaptic cleft. From there, the neurotransmitters are transported back to the presynaptic neuron by what's called transporter proteins in a process called reuptake. If the neurotransmitters were not returned to the presynaptic neuron by the transporter proteins, they would stay in the synaptic cleft. The longer they stay there, the longer they're able to rebind to the postsynaptic neuron and therefore continue to transmit the signal. You're probably thinking, wow, we're talking a lot about cells and chemicals and the brain and stuff, but what the heck does this all have to do with ADHD and Adderall? Well, it turns out Adderall is actually able to induce neurotransmitter release independent of neuronal firing to induce neural signaling in the absence of a stimulus. Adderall is composed of a mixture of amphetamine salts that are chemically and structurally similar to the neurotransmitters dopamine and noradrenaline. Since amphetamines are so similar to dopamine and noradrenaline, they can bind those two neurotransmitters' transporter proteins. Those transporter proteins can then take the amphetamine and bring them back into the dopamine and the noradrenaline releasing neurons. Once amphetamine is transported into the neuron, it induces the release of more dopamine and more noradrenaline. Because amphetamine is competing with them for their transporter proteins, dopamine and noradrenaline are stuck in the synaptic cleft, where they can stay and keep binding and coming off and binding again on the postsynaptic receptors. It's sending that signal to the brain repeatedly. Unfortunately, Adderall's exact mechanism in the brain still remains unclear. However, we do know that receptors for noradrenaline and dopamine are highly localized to the prefrontal cortex. Noradrenaline acts to strengthen synaptic connections in the prefrontal cortex. This allows it to regulate executive functions more effectively. Dopamine acts to increase what's called signal-to-noise ratio by inhibiting responses to irrelevant stimuli an increase in responses to relevant stimuli. Because Adderall binds to the receptors that are localized to the prefrontal cortex, it is able to increase the concentrations of noradrenaline and dopamine in that region. Research has shown that prefrontal cortex activity is significantly affected by concentrations of dopamine and noradrenaline. It's been hypothesized that impairments in prefrontal cortex function arise from either insufficient or excessive amounts of dopamine and noradrenaline. It's therefore hypothesized that therapeutic doses of Adderall are able to correct the concentrations of dopamine and noradrenaline and therefore improve executive functions. The evidence for this hypothesis has implications for individuals who use Adderall who do not have ADHD. Excessive stimulation from misuse of Adderall can actually impair cognitive function. This can cause inflexibility, which can be harmful in situations that require broad attention or creative solutions. Hopefully this has given you a little bit of insight as to how your brain works and how drugs might be affecting those processes. Thanks for watching.